Color is one of the tests used to identify minerals. For example, azurite has a nice blue color. But the problem with color is not enough to identify most minerals. For example, fool's gold on the left over there and real gold in the middle on the right. Well, real gold can have different colors between other different real golds depending on some of its composition. And then fool's gold and real gold can have the same color, yet they're not the same mineral. And then quartz and calcite, both of these minerals look very similar. They're both white. However, they are not the same mineral. So color alone, just taking a look at a mineral, will not tell you what mineral it is. You have to use some of the other tests to figure out what a mineral is. And the second test is a pretty useful one for that regard. Hardness. So hardness, how easily a mineral is scratched or how easily a mineral can scratch something else. Hardness can narrow down the possible mineral choices. Hardness plus color might not be enough on its own, but it'll get you pretty close. It'll either narrow it down to 2 or 3 different minerals for sure. So for example, a diamond with a hardness of 10 on the Mohs hardness scale can scratch pretty much anything else, while as talc with a hardness 1 can pretty much be scratched by anything else. So here's a little chart that you could use if you like pulling up charts off the internet. There are plenty of Mohs hardness charts on the internet. Let me go ahead and give you an example right now. So let's say you had a penny, and the penny has a hardness of 3.5. If you have a rock, and you were taking that mineral and you take it to the penny and scratch, and the penny gets scratched, then that rock or that mineral is harder than 3.5 on the Mohs hardness scale. So if the penny receives scratches, it's harder than 3.5. If the opposite is true, you go and instead of that, the penny actually scratches the mineral, then the mineral is lower than 3.5. So what is being scratched is the lower on the scale. If you take your fingernail and try to scratch the mineral and your fingernail doesn't scratch it, well, the mineral is harder than 2.5. If the fingernail does scratch it, then the mineral is softer than 2.5. It's lower, like it's either 2 or 1.5 or 1, or that's pretty much it. So using everyday objects, you could actually figure out what a mineral is on the scale. Now here's the thing. Test number 3 is luster. Now luster is the way a mineral reflects light, but an easier way to think about the word luster is how shiny is the mineral, or what shine does the mineral have, if any. So the first shine is probably the easiest thing about, and that is metallic. Does it shine like maybe a coin, which is made of metal, or galena, which is a metallic mineral, or maybe some chalcopyrite? Basically shiny like a metal. And there aren't too many metallic lusters out there. So if you have a mineral that is metallic, you've narrowed down your choices significantly. There's only a handful of metallic minerals, common metallic minerals, I should say. Now, if it's not metallic, like these right here, you have a few other choices it could be. So there's non-metallic. Vitreous is another example, as you can see on the screen right here. So vitreous and glassy are the same thing, basically, as shiny as glass. So glass is very reflective, very shiny. So here's an example of vitreous right here. This is some quartz right here in the middle as well. And quartz crystals are very shiny. There's some more vitreous as well. There are other lusters as well. There's dull. So we have metallic, we have non-metallic glassy or vitreous, and we have non-metallic dull. So while this might be glassy, this other side would probably be considered dull. Actually, let's go even more dull. This side would be considered dull. So you can see dull here on the screen or dull right here. So very, very not reflective, barely reflects light for dull. So those are the main 3 choices: non-metallic dull, non-metallic glassy or vitreous, or metallic. Now there are other lusters out there. There's pearly, there's silky, there's greasy, there's resinous. Okay, test 4 is density / specific gravity. Now for density and specific gravity, how much mass is contained in a given volume? I'm assuming everyone has covered density before. However, the reason density is very useful is certain minerals have a very specific density that doesn't vary very much. While quartz can have many different colors, quartz will always have a very specific density. Now, most rocks on Earth are going to have a density somewhere between 2 and 3, which doesn't really tell you much. If your mineral has a density between 2 and 3, Well, that's not very useful. But if you have a mineral like galena with a much higher density, or gold, which you can see down here, has a specific gravity of 19, meaning it's 19 times more dense than water. Yeah, it's going to be pretty easy to tell gold if you have a density of 19 or anything close to that. There's not many other minerals that are that dense. Maybe lead. Pyrite, on the other hand, fool's gold right here, you can see, only has a density of 5. So real gold is more than 3 times more dense than fool's gold. That might be an easy way to tell whether you have real gold or not. So density is pretty good. You can test them like that. Test number 5 is streak. So streak is the color of the powdered form of the mineral. If you take that mineral and you rub it against something that is harder than the mineral, it will leave some powder behind on the surface. So you can see here, these white things right here are ceramic tiles, the same tile you have in your house probably. And when you take a mineral and scratch across the tile, it leaves a color. But here's the thing, it's not always the same color as the mineral itself. So for example, fool's gold, which has a yellow color, when streaked across the streak plate, has a blackish streak. If you know it has a yellow color and a black streak, you can pretty much right there identify it as that must be fool's gold. If not, hardness or density could solidify that for you. Whereas this mineral over here, look, it's black, but you scratch it on the streak plate, it's red streak. So streak is another piece of information that can be useful when trying to determine what a mineral is. Now, not every mineral will leave a streak. Notice this image right here. 3 minerals here leave streaks. This one black, this one tan, this one red. However, 2 minerals do not leave a streak. So what's going on there? Well, it could be one of 2 things. Either one, these minerals have a hardness of 7 or higher, which means instead of leaving a streak on the streak plate, they're actually scratching the streak plate. And that's not going to leave any color. Or 2, the mineral itself actually has a white streak, which, for example, let's take a look at quartz right here. So quartz, there's many different colors for quartz. There's pure white quartz. There's amethyst, which is purple. There's smoky quartz, which is black. Aventurine, which is green. But here's the thing. All the quartz leave white streak. So streak isn't perfect either. Next test is cleavage or fracture. How a mineral breaks. Most minerals, when you find them out on Earth, they're broken. Sometimes they're not. Like, for example, these ones on the left here. Some of these aren't broken. That one is. But most minerals are already broken, which means you can tell what kind of surface they have. Do they break into cleavage surfaces or fracture surfaces? Now, I've got the definition for fracture already up on the screen. Fracture is rough, uneven surfaces. Think jagged edges. So, for example, this quartz right here has nice jagged edges. That's definitely fracture. So does this one right here. Nice sharp edges on this as well. So if you think of fracture like if you broke glass and that glass broke into nice shards and jagged pointy parts, that's fracture. Glass fractures, quartz fractures. Many other minerals actually fracture as well. Now there's also, let's talk about cleavage next. So let me go to the next page. Cleavage is when it breaks into smooth, flat surfaces. So like pictured on the right or pictured on the left here. So for example, this mineral right here, mica, also pictured on the left right here on your screen. Mica has nice, smooth, flat surfaces. Look at that. Even if I show you this edge, it's also got smooth, flat surfaces all at different angles and different orientations. Some are going sideways, some are going straight up, some are flat. But you can see this whole thing is covered in smooth, flat surfaces. That's how cleavage works. You can have flat sheets, like pictured on the left here. You could have rectangular prisms, like on the right here. But basically, if it's smooth and flat, it's cleavage. If it's jagged and rough, it's fracture. So that's it for cleavage and fracture. But now there are many different tests for test 7. Is the rock magnetic, or is the mineral magnetic? Does it glow under UV light, black light? Calcite is one example that does. Does it fizz in acid? Some minerals do. If they don't, then that's fine, because most minerals don't. Is the mineral radioactive? That really just narrows it down to the minerals, some mineral that contains uranium, because there aren't very many radioactive elements out there besides uranium that get caught up in minerals. Maybe feldspar